Wordley in the green room just before this new video. Got a couple of people to thank for this one because it was the result of some motivation and inspiration stumbled across this morning in a conversation with a couple of people on that social media channel that seems to be everywhere at the moment. So I would like to thank Doug Johnson for alerting me to the energy equation that relates to what the photon is doing and where it gets its energy from, and Jeff O'Callaghan for the post that initiated this discussion. Looks like Wordley's about to fly. Let's see where he wants to go. We all know about that. Oh! There you are. Wordley's exercising his wings now, although he is not travelling yet faster than the speed of light, which is what we're going to look at today. Right. Photonic inference then. A subject somewhat dear to my heart because I have contemplated for a long time over the years as to how the speed of light can possibly be a limit in the universe, and it's a question that's not really readily satisfied by the science surrounding it, from my point of view anyway. And that doesn't mean to say that the science is wrong. It doesn't mean to say that Max Planck was mistaken. So I'm looking at this from a slightly suspicious angle, understanding the confirmation bias that goes with this kind of territory. And this is the equation that Doug referred to in the text conversation on social media I've just told you about. Energy equals h, which is Planck's constant, i.e. the speed of light, and f, which stands for frequency. Now, the photon itself is massless. Okay, it's a light particle that carries no mass. The mass energy equivalence doesn't apply, can't happen. So this is instead where the photon is said to gain its energy from. It gets its energy from light speed, from the speed at which it travels, and the frequency at which it operates. We know that right across the electromagnetic spectrum there are different frequencies of operation that the photon takes part in, and we talked about this in previous videos. So, knowing that and understanding that these frequencies are changing, so at one end of the spectrum you've got the very, very low frequencies, the radio frequency being the lowest of them all, very, very slow, and then the gamma at the other end of the EM spectrum being the highest that we know about anyway, and obviously extremely very fast, very high. And in between, for a little slice, we've got visible light. And visible light is where it all seems to happen for us. That's where our points of reference are. Now, the speed of light is a measurement. It's measured by the amount of time that it takes light to travel. That's why we have light years to measure distances between stars and galaxies. And we understand the speed of light to be a limit because, as far as we can tell, as far as we can see, nothing in the universe can travel faster than this light speed. But you've got to bear in mind, haven't you, that what we're talking about here is light that we can see. So light, therefore, that travels within the visible light spectrum that we can measure. Now, If you get beyond that, then you get into all sorts of complexities typified by something called the ultraviolet catastrophe. And the ultraviolet catastrophe is just a bit of a problem, really, in terms of what happens to radiation when you're looking at it from a black body point of view. Black body is something that absorbs spectral radiation, as far as I can understand it. Because this photonic inference that speed of light is the limit to which everything in the universe must subscribe and apply itself, just sounds to me a little bit like saying, well, we can see this, we can see this in action, and so therefore it's got to be that way. However, let's have a look at the concept of annihilation and those Feynman's diagrams that I've shown you in previous vids. This essentially is illustrating what happens during the annihilation of an electron and a positron, and this slice of time, this minuscule slice of time in which a photon exists before it decays into a gluon and a quark and another quark. Sorry, let's try that again. Before it decays into a quark, an antiquark, and an antigluon. And that slice of time is really quite unfathomable. And all the equation will tell you is that that photon is there. So if we bear in mind the uncertainty principle, it's very easy to tell where something is as long as you're not measuring the speed at which it's travelling. We can see that even these equations that introduce the photon as a catalyst, a catalytic converter if you like, from one set of particles to another, really cannot truthfully and honestly, hand on heart, be said to be happening within the light speed limit. Unless, of course, you can measure the position and the momentum and the speed at the same time, which you can't. So that essentially is the problem that I'm putting forward here today. Just to give you another piece of information about this h that Max Planck gave as a symbol for his constant. He came up with that symbol because he couldn't think of what to put on the speed of light as a universal constant. What do you call a universal constant after all? What do you assign to it? And he came up with h in relation to the word heaven. And that in itself is a little bit of a clue, if you like, to the human reference mechanism that we use for everything. We got Planck's constant as an h and f for frequency. So the frequency of the photon, i.e., how fast it's vibrating, is equal or equivalent to the energy that it puts out. Part of the problem, and one of the reasons why I've been investigating this and jumped on here today ready to chat with you about it, is that the electron absorbs or takes on a photon in order to jump up a level in the shell valence within the atom. The electron is a fermion. It's an elementary indivisible particle. So is the photon an elementary indivisible particle. So how a fermion can blend with another fermion,
I don't know.
but this seems to be part of the structure within the matrix of scientific terminology. And the electron then releases or emits a photon in order to drop down a level on the shell valence. Remember, the higher on the shell valence the electron is, the higher its energy. So it's effectively absorbing a photon in order to gain energy and leap up in its own energy level. More questions there then for you to investigate and potentially answer. I'd love to know what some of those answers might be. Thank you very much for watching, and there are loads of videos out there that say what you should do at the end of the video, but I'm going to leave it to your discretion, because of course I'd love you to be here with me, of course I'd love you to be joining me on this journey and see how far it takes us, because there is so much more to come. And there is so much exploration to happen in the quantum realms that there really is no limit. Unless, of course, we choose to put limits on, which we don't want to do here today. Anyway, enjoy your journey. Have fun with it. Bear me in mind, because I'm here to join it with you. Take care of yourselves. Love you lots. See you soon. Bye.